Take a look at this beautiful field full of so many different flowers and colors. But what's this? A gas-powered airplane is flying through the field. Oh no! Due to all the fuel emissions the plane is giving off, all the flowers are dying and the air is getting very polluted. But don't worry. All hope is not lost yet. Here is an electric airplane. Since the electric plane runs on power and not fuel, the flowers will slowly start to come back to life, and we will have more fresh and clean air. Hello, my name is Stephanie, and these are my colleagues Shri, Lucas, and Lena. Today we'll be discussing and introducing to you our idea and research on electric planes and how they can better our environment.
Now you're probably wondering, why should we care about electric planes? Well, the airline industry is responsible for approximately 5% of global warming. This is a large amount that can be mitigated using electric planes.
Here are all the components of the electric plane who will be covering them. The electric motor will be covered by Shri. The batteries will be covered by Stephanie. The regenerative brake will be covered by Lucas. And lastly, the lightweight material and airframe design will be covered by me, Lena.
What's the most important thing to make something work on electricity? Make it electric. The first component of the airplane that we will be researching is an electric motor. The research question for this is, how does the electric motor use the energy it receives to propel the plane? The engineering theory that I'm going to be using to answer this question is electromagnetic induction. The goal of this research is to use the electrical energy to generate the thrust force of the plane to avoid using a pressurized gas release, since that is what puts toxic carbon emissions into the air. The function of this electric motor will happen using electromagnetic induction, as I said before. The electromagnet shown has a magnetic field around it, and this magnetic field generates an electric current inside the rotor through electromagnetic induction. You can see the interaction between the two fields on the image on the right. That is what produces the mechanical forces that turn the rotor. To summarize, the process of electromagnetic induction produces electrical energy that is converted into mechanical energy. This mechanical energy is generated through the process I said earlier and is used by the electric motor to produce the thrust force to propel the plane into flight. Next, Stephanie will talk about batteries and how they contribute to the electric plane. These batteries are what power the electric motor.
Imagine having your own personal private jet that just ran on electricity alone. An invention of the future is now one step closer, and one of the reasons why is because of electrochemical reactions. There are also many factors to consider when we're curious about electric planes, such as what factors affect how long electric plane batteries last, how much energy they store, and how we can improve these aspects to make this electric plane even cooler and more efficient than before. Today, all those thoughts and questions will be answered. First off, what is an electrochemical reaction? Imagine the reactions as a dance party, and there's two guests, the electrodes and the electrolytes. While these two guests dance together, they swap electrons, creating an electric flow of energy, which powers many different things, such as your phone or our electric airplane. Now to answer our burning questions. One is, what factors affect how long electric planes batteries last and how much energy they can store? Imagine the battery as an athlete. First, we consider temperature. If the temperature is either extremely cold or extremely hot, it can strain the athlete and battery's performance faster, as well as its overall lifespan. It's similar to when you try to use your phone in freezing cold or ridiculously hot weather and it's not working. A battery is just like us. It prefers cozy weather environments that's not too hot and not too cold. Next, we need to consider the charge and discharge rates. This is like the heartbeat of the battery. If the rate is too slow or too fast, it could affect how long the plane stays airborne. Just like the technology we have at home, the battery of a plane thrives when its charge and discharge rates are just right, which helps for long-lasting performances. How can we improve these aspects that makes this electric plane even cooler and more efficient than before, you may ask? Well, imagine upgrading a regular battery to like a super battery. Researchers are exploring advanced materials for electrodes and electrolytes, creating a battery that will be so much more efficient and long-lasting. Also, better technologies such as battery management systems act as the brain of the battery, optimizing its health and peak performances. We want to conserve all the energy we can to use them on our flight. To our next speaker, who is Lucas, who will so happen to talk to us about conservation of energy. And unpin. And one second. Sorry. Okay, there we go. Or wait, sorry, let me mute.
Hello, I'm Lucas, and my subtopic is regenerative braking. The question I aim to answer is how a regenerative braking system can maximize the energy recovered during the descent and landing of an electric plane. Conservation of energy is the fundamental theory that is experienced every day. In physics, it is impossible to create or destroy energy. The only way energy changes is through conversion. This means the input energy will always equal the output energy of a system. Energy comes in many different forms, including kinetic, thermal, potential, and electrical. Figure 9 and 10 show an energy transfer from potential to kinetic. When a plane is starting to descend, it must do two things. First, it needs to dump excess lift to lower the altitude of the plane and decrease the potential energy. Secondly, it needs to bleed excess speed to decrease kinetic energy. This act of bleeding energy is a major source of waste. Ideally, the plane would not need to dump this extra energy, but that would require an unsafe and uncomfortable flying experience. The alternative is effectively regaining energy that is being wasted. The regenerative braking system will use the theory of energy conversion to harness the kinetic energy of the plane and convert it into useful electrical energy. The system will harness the power of the braking wheel, as seen in step 1 of figure 11, by turning the generator in step 2. This will create electrical energy, which will then be safely converted in the power converter in step 3. This energy can then be put into battery storage in step 4 to extend the range of the plane. An effective regenerative braking system needs to apply enough braking force to safely slow down the plane. As of right now, regenerative braking can only apply approximately half of the overall braking force required to stop a high-speed vehicle. The other half of this required braking force would need to be conventional friction brakes. You can see this in figure 14. Overall, a regenerative braking system is extremely useful in energy recovery. By making use of the theory of energy conversion and expanding technologies, it becomes more feasible to maximize the energy recovered on descent and landing of an electric plane. Thank you, and now Lena will discuss lightweight materials and airframe design and how they contribute to an electric plane.
You might be wondering how can we make planes fly using less energy? You might also be wondering why is it important that the electric plane is built from lightweight composites and how can the airframe design contribute to reducing energy consumption? My subtopic is lightweight material and airframe design, and I will be using aerodynamics to answer these questions. One of the key strategies to conserve energy in aircraft design is incorporating lightweight materials such as advanced carbon fiber composites, which these end up replacing the metals that are used in traditional aircraft designs. The substitution results in significant reduction in the plane's weight. This would lead into a decrease in fuel consumption by 5%, and this will allow the airplane to travel efficiently. Another technique for conserving energy is the design of the aircraft's body structure. The blended wing body design can be seen in figure 17, and then the box wing design can be seen in figure 18. The relationship between weight and the aerodynamic forces is very important to understand. Alright, so the aerodynamics is how the air acts around the motion of an object. The forces acting are lift, weight, and thrust and drag. These allow the airplane to fly, and with the airflow around the wings, you can see here in figure 20, the pressure of the air allows the wing to have lift, which would provide the airplane to go up. For the airplane to continue going forward, thrust is provided from the motor, and in this case, it would be the electric motor that Shri talked about. Drag is also provided by the airflow, where the friction between the air and the wing causes it to go the opposite way of the airplane. And then weight is just provided by gravity as it pulls it downwards. All right, so why is it important that the electric plane is built from lightweight composites, and how can the airframe design contribute to reducing energy consumption? This is because the lighter the plane, the less weight forcing on the less weight force acting on the plane, as well as less energy consumption during the flight. Also, the better airframe design, the better the airflow around the plane, which provides better lift as well as less drag. All in all, aerodynamics is an important engineering theory to examine in designing electric planes.
To recap, our goal is to research how to design electric planes and modify all the components of a regular plane in order to accommodate for it being electric. This would involve an electric motor that uses electromagnetic induction, batteries which use electrochemical reactions, a regenerative braking system that uses the law of conservation of energy, and a lightweight material and airframe design that uses the law of aerodynamics. These electric planes will help severely reduce the number of carbon emissions polluting the air when the multitude of planes are used every day. If you're interested in learning more about electric planes, please do research more about the theoretical functionality of electric planes, as it is a critical component to reducing air pollution around us. Thank you.